All right, welcome back. Today we're going to be looking a little different, see if Stolte can figure out, that's me, if I can figure out this technology. Here we go. It's AW 2.9, folks. We have here the graph of the sine curve. So just like we saw last time, it takes 2 pi to go all the way around the circle, right? And remember, these are the y values around the unit circle. So here at 90 degrees, the y value would be 1. At, I can't make my arm go that way. At pi degrees, sine is back to 0. Or I'm sorry, y is back to 0. And then we go along the unit circle, it gets negative down to -1 at 3 pi over 2, and then back to 0 at 2 pi. So like I hinted at before, of course, we can shift and transform the graph of sine using the same transformations we've done before. I want you to notice that actually for this sine graph, it has a midline. Now, aptly named, the midline is in the middle of the graph. And if I shift this graph up 1, right, adding 1, then it makes sense that the midline of the graph also shifts up 1. Surely then that means I could shift it down 2, and my midline would shift down 2 as well. So here, nothing too crazy, right? The y values for this vertical shift down 2, each of the y values would then come down 2 as well. Great. Our other vertical shift transformation that happens, though, is a change in, actually keep my midline there just for fun, is a change in the amplitude or the heights of the graph. We know that if I multiply my function by 2, we know that's going to cause a vertical stretch. So what does that look like for sine? Well, the points along the midline, notice their y values were 0, so 0 times 2 kept them the same, but the rest of the graph got stretched up 2. This is called the amplitude of the graph. It's the distance from the midline to the peak, or again, from the midline to the valley. I could make my amplitude all kinds of different things. Notice an amplitude of 3, or a vertical shift, a vertical stretch of 3 moves it up to 3 and then down to -3, or to 4 goes up 4 to -4. Our normal sine graph, of course, having an amplitude of just 1. And again, working with normal sine, then we also know, of course, as we think about those vertical stretches, you could do a vertical compression, right? Multiplying by something like a half would change my amplitude to a half instead of 1. And that multiplying by a negative would flip my graph upside down, right? The same vertical reflection that we've seen before. And we can combine those vertical transformations to get all kinds of different graphs. Here, let's say I was going to look at a function and I wanted to move my graph up 3, but give it an amplitude of 2. I want you to try visualizing that before. Right, so I'm moving my graph up 3, and the amplitude is being stretched by 2. So moving my graph up 3, we should also be able to kind of visualize, all right, that means my midline would be up at 3. And if the amplitude is 2, that means my points are now going to 5 and to 1. The graph is oscillating between 5 and 1 because, again, that amplitude of 2 is 2 from the midline. So what we're going to look at is how do we figure out what transformations happen? Okay, I'm back recording, and you guys, honestly, I think I'm going to get really fancy with this. If I was trying to figure out, I'm pretty excited, what was happening with this curve? First off, this is the graph of sine. We're just going to assume they're all sine. Right here, even though in Desmos it doesn't quite give me my radians, I could set it to, but these aren't radians along, I'm sorry, they're not in exact values of radians along the x-axis, they are in radians. I can see, and we'll just assume right here, I'm not going to give you any tricky ones just yet, that this is still 2 pi. So one cycle of sine took 2 pi, the period of the graph hasn't changed. We can, of course, though, right away see that the midline of the graph has changed, right? So the midline of the graph is still at -1, So I know at least my graph would be sine of x minus 1 because it's moved down 1. But the other question to look at, again, from the midline is what is the amplitude of my graph? From the midline down to the peak or up to the valley, up to the peak or no, whatever you guys. We can see that the midline to the valley is 3 and the midline to the peak, of course, also 3. Those are always going to be the same distances. Middle would be the middle of the graph. So really looking at this function, I can see that there has been a vertical stretch as well, and this should actually be 3 times the sine of x, and so my function should be 3 times the sine of x minus 1. For the big reveal, let's take a look. That's exactly what we had. All right, so here's another example, trying to figure out the midline, any amplitude changes, or any period changes to this graph. I know I lied to you, right? I said I was going to give you a change in the period, but then I decided let's not be too much. So the period of this graph, kind of hard to see. I don't have the midline here, but maybe you can kind of see here that the midline is at 4. And that period there ending at 2 pi checks out. So we know there's been a vertical shift up 4. And then once again, I'd look at the midline to the peak, see that that's 2, amazing. And we might be tempted to be like, great, we got it. So it would be y equals 2 sine of x. We might be tempted to think it's just 2 sine of x plus 4. That got so messy so quickly. But we can see that because this graph has flipped upside down, normally the graph of sine, right, normally it would go up like so. That would be my normal graph of sine would go up because it doesn't start off at 0 or doesn't start off at the midline and go up. It starts off going down. We know that should be a negative out front, which is, of course, what we see here. Dear God, I got to stop with this recording and let's move on to your asynchronous problem then for today. Here is our asynchronous assignment. Can you write the equation of this graph? It's one of our trigonometric curves, a sine curve for today, including any vertical or horizontal transformations. All right, as always, I look forward to seeing your work. Submit a picture, ask me your questions. Y'all, we're gonna make it.